Hey everyone, in this lesson you will learn how to fit a line to data and model the data with a linear equation. Before we begin, let's recall how we can describe the correlation of data on a scatter plot. This first example here, if we were to relate these points, has a positive correlation, and this second one, if you recall, since it looks like it has a negative slope, if we were to fit a line there, has a negative correlation. Using your guided notes, read the first example to yourself. This question is asking us to write an equation, which we've been doing, that models the number of clusters as a function of the number of years since 1990. So whenever you're given data, the first thing you want to do is plot the data. The first step to writing an equation to model the data is to make a scatter plot. And on our scatter plot, we're going to label our XY axes as the number of years since 1990 on the x-axis. So on the x-axis, the number 1 would represent 1991, because that's 1 year since 1990. We're going to let y represent the number of active clusters for this data. I want you to pause the video and make your own scatter plot. So set up the XY axis the way that I did, with the x-axis being labeled years since 1990, and then the y-axis being labeled the active clusters. Your scatter plot should look something like this, and as you can see, this has a positive correlation. So if we were to try to fit a line through here, that would look something like this. Alright, the next step after you do your scatter plot is to decide whether, and you should write this down on your guided notes, decide whether the data can be modeled by a line. And the answer to our example problem is yes, and I already demonstrated that in the last slide. We are able to fit a line there because it shows some type of correlation. In our example, it showed a positive correlation. So then the very next step is to just draw that line, which I already demonstrated. So on your scatter plot, you should try to draw the line that best fits all those points. So draw the line that appears to fit the scatter plot closely. Okay, so after you draw that line, just trying to fit it into the scatter plot as close as possible, the final step is to just go ahead and pick 2 points from your scatter plot where the line touches. So pick 2 points. And for this specific example, why don't we just pick 2 of the points from our table, 2, which represents 1992, comma 20, and the point 8, which represents 1998, comma 42, and then once you pick your 2 points, then you can write the equation. Because remember, once we have 2 points, we can find the slope and we can write the linear equation. Using those 2 points that I just arbitrarily chose from the data, you could have picked any 2 points from your data, but I chose those 2. We're going to first find the slope. So in order to find the slope between 2 points, remember you just take the difference of the y's and divide by the difference of the x's. So let's take 42 minus 20, those are my y values, and divide by 8 minus 2, those are my x values. Alright, pause the video and see if you could calculate this on your own, and then check your answer. You get 22 over 6, which is 11 over 3 when we simplify it. So there's our slope. From there, we want to then figure out what the y-intercept of the line is, or at this point, we could use point-slope form. It's really up to you, but I think most people prefer to write it in slope-intercept form. So let's go ahead and use the point that I chose 2, 20, just so everyone's using the same point. So let's use that point and substitute our values in for y, m, and x, and then we'll solve for b. So our y value here, remember, is 20. So I can go ahead and put in 20. The m, or the slope, was 11/3, and my x value is 2. So now all we have to do is simplify and then solve for b. Alright, so simplifying everything, you should have gotten a b value of 38 over 3. So now all that we have left to do is actually write the equation. So remember, if we're writing this in slope-intercept form, y equals mx plus b, the only thing we have to do is now replace m with the slope that we found and b with the y-intercept that we found. So this final answer is y equals 11 over 3x plus 38 over 3. And you could also simplify these fractions, or not simplify, but evaluate them and write them as decimals. That's another way to do it, but that's the equation of the line. So in the next slide, you'll see how we actually write this answer, because it is a word problem, so we're going to answer the question. So to finally answer the question that we started with, the number of active woodpecker clusters can be modeled by the function y equals 11/3 x plus 38 over 3, where x is the number of years since 1990. I know that sounds all formal, but that is the answer to the problem, and you just found a linear equation to model the situation. Great job. That's the end of this lesson. I hope you enjoyed.